Good day to you. It's about 4 a.m. in the morning here on a Saturday of August from Chico, California, where I have been looking at the moon. Oh man, there's no higher form of wisdom than looking up. That's where you're going to get your real answers. In the prior video, I had promised to introduce you to certain aspects of worldwide wisdom, mostly from the deep past, because that's where it comes from. In one sense. But I also promised to go through the cosmic units. When I first began this video series 3 years ago, my opening video presentation was on the two directions in which you can look to get knowledge, which is for science. Which is for what? That's what we're going to talk about. What is science for? Because it's such a tiny part of life. Most of life is emotion-based, such as love, fun. Those are irrational. That doesn't mean bad. It means the other side of you. But when I first began, one of my goals was to teach astronomy in a way that you just don't get. Nobody talks about astronomy the way I do, which is by cosmic units. Now, there's various ways to classify things in the sky. And that's a good place to begin. I always like to give a little bracketing information so you know what we're focusing on. I like to say that there are two directions, and that has context. It's an abstract statement. It could be applied to many situations. There are two directions. For instance, emotion and logic, the two subsystems of a human being. You're either emotion-based or you're logic-based. Try to be one or the other. You have to be both. So there is a balance. That's what I'm all about, is balance. I know, but we we can't always be balanced or we'd never have fun. We're competitive, not to be mean, but so we can laugh. We can exist together. We're meant to exist together. We need each other. So that's one aspect of life. In applying this maxim that there are two directions, so let's go through the cosmic units that have been discovered in science. One of the main purposes of strict science has been to figure out what's going on in the celestium. Celestial mechanics, we're talking about Kepler, Copernicus, Newton, Ptolemy, going all the way back to Archimedes, to the beginning of human history. All cultures are astronomically oriented. Because you can't avoid looking at heaven, first you see that the birds are flying, and it's like, wow, how come I can't fly? Something, I'm just saying as an example. You look at the moon, you gotta wonder. That thing looks like a perfect circle. Well, that's your introduction to geometry, which is going to sustain you throughout your whole life, is to know about geometry, which is not just straight line, the right angle law, misnamed the Pythagorean theorem. You shouldn't name scientific things after men, but it's a habit that men have developed in Europe to name things after men. Now, a lot of people don't like that. Take a wide view. Don't be always like-dislike. Yes, you have an emotional reaction. Yeah, I don't like that. I don't like my string beans. Well, then you're going to miss out. That's your tough luck. Your parents are trying to do you a favor by, eat your string beans or you won't get any ice cream. Well, that's the two sides of everything. So looking up and out, what do you see? Well, in science you want to do classification, which comes about as a empirical process. You start out by going, what's the moon? What is that, mommy, daddy, astronomer, wise man? What's the moon? And they'll tell you something either mythical or they don't know and they just guess. Because you have to answer the kid. You're an oldster. You're supposed to be teaching the children. Well, you get what you get. You don't have any choice. Your society, your culture, your family, your nation, they're going to tell you the answers to your questions according to what they think they figured out. But you do have to have a balance even classifying science. Because you have to look at things. There are things. You look at the finches, if you're Darwin, and you say, my goodness, they're all different. These finches have different beaks. They have different everything, but they're all finches. So they're all the same in the sense they're all from one genus. But they're all different because they have a locked DNA code called a species, so they don't interbreed. That's a species. It's a form of life on Earth that only interbreeds with its own kind. That's called a species. It's a locked code. The finches, whatever kinds there are hundreds of finches, but they're all finches. So Darwin extrapolated and said, well, they must have speciated from a superfinch. That's a very logical conclusion. Can you prove it? Very difficult to prove, but it's unavoidable knowledge. You see it. So you see things. Well, then you classify. And which comes first, the chicken or the egg? Try to avoid answering nonsensical questions, unanswerable questions, paradoxes, conundrums, riddles. In science, you have to ask a yes-no question to use binary logic. It's very restricted. It's very restrictive. But man, is it powerful. Because instead of going, yeah, well, I don't like it, well, then you're done. You're never done in science. You don't turn away from anything. A scientist is the most courageous person. All right, so the cosmic units. Well, the first one that we know of is the Earth. Is that a cosmic unit? You would probably start out by saying so if you're young and from some culture at any time in history. Yes, the Earth is a unit. But then you find out, and this is an historical development, but now we know because we've developed telescopes to check, are there other things that are like the Earth? Yes, they're called planets. And that's science. It's those two things. There are things, but there are classes of things, and they may be hierarchical. Well, going out, they are hierarchical. So let's begin with a cosmic unit. The planets. That's a cosmic unit. Is there anything smaller? Yes, there are satellitic bodies, such as the moon, called satellites of planets. So now you have two things to think about. The Earth and the moon. This is why I love talking about the moon, especially with children. They really respond to that because they can see it. And it's fascinating. Why is it perfectly round? That's a perfect geometric figure in the sky. And it changes, so you get your first glimpse of the effect of change. And then you might want to study the I Ching, which is about change. There's a whole abstract framework for thinking about time, which is the medium of change. You would have to admit there's some form of motion. Now the cosmic units, you can see right away. We learned this in elementary school. There are planets. There are moons of planets. Jupiter has like 12 main ones. Certainly the Galilean moons of Jupiter are very famous. There are 4 of them, which is kind of arbitrary, but they're the most visible ones. More learning, there are various scales of size. So you begin looking up, not at the Earth, not looking down or in or sideways. You're looking out to what you can't reach. Although we have landed on the moon and we have landed in other places in the solar system. But that's the beginning of your framework. There are things that fall into classes. So you have planets. You have the satellites of planets, which are smaller, so that's lower on the hierarchy. Well, what's the next unit up? I think you can guess. It's the sun. And according to my developed classificational system for cosmic units, that is the first cosmic unit. It's not planets, it's not comets, it's not meteors, it's not gas or dust, all of which exist in the solar system. It's not moons, it's not satellitic bodies. Deimos and Phobos, by the way, are likely not moons. They're captured large asteroids because they're not spherical. All bodies are spherical in my classificational system because you're trying not to leave anything out, but now you have logical niches. So the first cosmic unit is luminous. That turns out to be extraordinarily simplifying when you get to larger scale objects such as galaxies, clusters of galaxies, the cosmic web, the microwave background radiation, quasars. These are ginormous, right? Which is a wonderful word. It's a conflation of two words, as you know. Gigantic and enormous. Well, we say ginormous because we're always trying to make bigger and bigger numbers to express the almost infinite, seemingly infinite, collections of things in the universe. So you're getting a grip on reality that has perspective so that things make sense. So the best classificational system that I don't think it can be improved upon, is you classify everything in the universe by cosmic units, and you define the cosmic unit this way. It's a luminous object. Well, right away you know that there are two kinds, because stars are units, but galaxies are made of stars. So you just learned something. And we can proceed from the star to the next cosmic unit. Guess what it is? Hesitate there before you answer, because there are star clusters. And there's a special one called a globular cluster, which is almost galactic. So let's slow down here. You can learn how to address this question. Are globular clusters a cosmic unit? I say no for this reason, because we already know that a star has subunits. A star will have planets, and planets have moons, or satellites, as they're called. So when you say that the star, in general, is a cosmic unit because it's luminous, you're including in that category the things associated with the solar system. So that makes sense. That's simplifying. Science is largely simplification. Well, you see, there's two aspects to that. It's complexification. You're looking at more and more stuff, but you're also trying to simplify what you've seen so you can classify, organize, database. It's cross-indexing so that you can use your mind efficiently. So the star is the first cosmic unit. We'll just say that, but you see, you'll have a chapter heading, stars, and then underneath there's planets, moons, comets, asteroids, and other things perhaps. Because we haven't seen all solar systems yet, although we're trying. So that's the first cosmic unit. What's the next one? Galaxies. And then in the chapter heading galaxies, there are globular clusters, there are star clusters, there are binary stars, there are trinary stars, there are even quaternary, called a four-body stellar system. So where do those go? Right underneath the first cosmic unit. Actually, in this case, under the second cosmic unit, the galaxy. So now we have two. You can see what we're doing is we're expanding our scope, because the solar system is local. It's relatively local. And as you go out, you see there are more stars, and some of them are in clusters, but then you find out exactly a century ago, really between a century and 150 years ago, men realized that there are other giant star systems, such as Andromeda. Long before Hubble, actually about 50 years before Hubble, it was surmised without apparently sufficient proof in consensual science, but there was definitely a strong theory of island universes. I believe it was Immanuel Kant, not really considered to be a scientist in the sense we're talking about the hard sciences like astronomy, but he surmised that there are other giant star systems. Well, that's the second cosmic unit. We now know that that's true. We live in one, that is, our solar system is inside a galaxy. So that's the second cosmic unit. There are two criteria now we can decide on to define what we mean by a cosmic unit. It's a luminous object, but it may not be a unit in one sense that it's composed of smaller cosmic units. That turns out to be correct. So let's go on and expand using this perspective, this framework. Very efficient, very helpful to be able to think this way, because now all stars are in one class. They're stars. There are different kinds of stars, as you know, but they're stars. They exist as a single, coherent, cohesive, gravitationally bound unit of plasma, mostly. The fourth state of matter, plasma. Now, there's one other definition we want to include so we can embrace the whole universe if possible. That's our goal. I think you know it is possible, but we haven't seen everything yet, and we're getting there when we get to the edge. I'll show you the cutting edge of current astronomical science, astrophysics. So we have two cosmic units. We have the star, which is a coherent unit, it's spherical. But then we have galaxies, and they're made of stars, and that's what makes them luminous. Nothing else does. So the second principle that defines what we mean by a cosmic unit, it's luminous, and it statistically fills the universe. So stars make up the universe. Well, you see, there's two sides to that. Stars make up the universe statistically because all the luminous objects, I'll just say to a certain threshold of historical science, that's the only cosmic unit that's a unit, is a star. Whereas a galaxy is called technically an extended object because it's fuzzy until you resolve it using photography. That's how we know about galaxies. Hubble could not have as quickly discovered what he did, first of all, without telescopy, you know that, but also not without spectroscopy, which is the analysis of light, and also one other aspect, photography. A major discovery that occurred, you could say, just in time as part of the Industrial Revolution, historically, broadly speaking. So this is a very large-scale principle of how to organize knowledge into understanding. You start out with a luminous object. That's the cosmic unit, but there's one other aspect to it. It statistically fills the universe. That's going to become important as we go on. So let's go on to the third cosmic unit, which was discovered about 30 years after Edwin Powell Hubble made his official discovery of the island universes, which he to his dying day called nebulae, which means a fuzzy object. But he never used the word galaxy, and I believe it's fair to say he was the last man to just exclusively use the older word for galaxy. I looked up once whether Hubble ever did use the word galaxy. He wrote a whole book called The Realm of the Nebulae, by which he meant explicitly the realm of the galaxies, the second cosmic unit. Pardon me, I had to put this on pause to get some more water. Jolly water, one of the miracles of nature. My goodness, do I love it. Especially due to the climate where I live. All right. And I also realized I'm not modulating my voice. One of the primary reasons for me to be making videos originally was to hear myself speak, partially for the reason I don't talk like this all the time, just raising my voice, making it crackly. No, you want to talk more like a British professor, if you can manage it. I'm still learning. I'm a slow study. I don't catch on to things quickly. But if you persist, if you keep going, you'll make it. Doesn't make any difference if you get that big R word, which I'll just say might have been applied to me at one time. Could still be for all I know. But you don't want to be the big red R. You catch on quickly. Well, not all men do. And I'll just say I'm a little bit of both, like most men. All right. So I'm going to try to modulate my voice as we go on to the third cosmic unit, which was discovered by my beloved teacher, Fritz Vicky. He's given credit for this, although he's mostly known for his discovery of dark matter. And he's the one who gave it its name, Dunkle Materie. He was Swiss, although, well, we won't go into Fritz Vicky. We're talking about cosmic units. So he discovered the third cosmic unit, which you might guess are organized systems of galaxies. That is correct. And he was able to prove using the virial theorem, which is an advanced mathematical concept, but rather easy once you study it and learn it. He used the virial theorem to prove that galaxy clusters are separate objects. They never overlap, although they do collide. But it's because they're separate objects that are colliding. You know, if two cars crash together, it doesn't make one car. But we'll talk about colliding galaxies and colliding clusters after we're done with our survey. This is a great thing. You want to make two columns when you're keeping notes. One is for your main sequence, and the other one is for footnotes. And those footnotes, you've got to keep track of them because they're everywhere. Yes, you know, we do have cosmic units such as the star, the primary cosmic unit. It's luminous and it statistically fills space, but solar systems have planets, and then you know, there's a bunch of footnotes. So you put that in the second column while you're going through your main sequence. What are the cosmic units? Well, now we have 3. By the way, just so you know something about clusters of galaxies, if you're unfamiliar with them, there are about 300 to 1,000 galaxies in a cluster on the average. All right, so there's our third cosmic unit, and now we've gone out much farther. The solar system is relatively local. We measure it in astronomical units, which you may or may not be familiar with, but it's just a way to measure space in a local region. What do we mean by local? Not the next star. The next star is light years away, as you know. So that's a bigger scale. We're going out. And then when you get to the galaxy, you're talking about 1,000,000 times further than the nearest star. You can look that up. I'm within the right range. That's called an order of scale. Very convenient to learn orders of scale. Usually they're decimal orders. The next higher scale is 10 times bigger. Well, in this case, the next nearest galaxy, when compared with the next nearest star, this would be with the sun at the center of our system, conveniently, another footnote. You have a star. Well, how far away is the next star? You can compute the ratio. For instance, within the solar system, we use astronomical units, which is the distance from the sun to the Earth, is called 1 AU. And you can compare that, and you need to do some mathematics, but it's simple. What is the ratio of 1 AU, which measures the solar system? It's about 50 to 80 AUs. And then you go out, well, how much farther away is a star? How many AUs? And you can compute that. But it's much more convenient to use light years at that scale. What is the scale for the next galaxy? And you would use that unit, not a light year. Although it has been measured in light years, it's on the order of a couple of million light years, which is much farther than 50 to 80 AU. Okay, so I think you got that. By the way, that 50 to 80, you may want to look that up. Excuse me. I eat some interesting food that gets caught in my teeth. That's a little bit of a fib. It's not food, but never mind. Don't worry about that. But I'm sorry, I should have checked my teeth before making this video. Well, I'm fallible. I'm sorry. And I should be sorrier than I am. Well, you don't show it. You showed us your nasty food-encrusted teeth again. It's not even food. What's going on here? You're not reputable. Oh, everything fits. That's another thing you learn in science. Nothing is completely disconnected from anything else. Although there's scales, of course. An atom is not quite the same thing as the cosmic microwave background radiation. Pretty much two opposite ends of a spherical spectrum. All right, so we have 3 cosmic units now. Do they have names? Yes. There's the star, very well accepted name for the primary cosmic unit. It's luminous, and it statistically fills the universe. After that, we've decided the galaxy is the next major class because it statistically fills the universe. You could say the universe is made of stars, but wouldn't you be better off, in the sense of perspective, to say that the universe is statistically filled with galaxies? Yes. Well, then there are clusters of galaxies, and that's the last primary. So now we've added to our system. There are luminous objects that we're calling cosmic units, beginning at the star, which is the only, so far, in our journey outward, it's the only one that's a coherent body, we would say, a ball of plasma. A spherical ball of fiery plasma is a star. What's a galaxy? Well, it's a big unit of stars, which are separated from each other by on the order of 1,000,000 light years. That's a reasonable statement. We're using ballpark figures. Now, to go to the next scale, how far apart are galaxy clusters, and do they have a name? Well, they have a name. They're called galaxy clusters. So it hasn't been named. I named it, so I'll just share that with you. Going on the analogy of nebulae, which is the older term for galaxy, I came up with cumuli. And so you could say stelli for star, which is Latin. So stelli, nebulae, which are galaxies, and then cumuli. These are the first 3 cosmic units going out in scale. Is there a larger unit? There is. But there's only one more. So there are 4 primary cosmic units. The star, the stelli, the galaxy, the nebulae, the clusters of galaxies, the cumuli. Do those form a larger structure? Yes, and they used to be called superclusters. But now we know that it's actually one unit called the cosmic web that have nexal points, that is, concentrations of cumuli. You see why the term cumuli is now efficient. Because instead of saying galaxy clusters, you say cumuli. And what does it mean? Galaxy clusters. But it's just a single word that fits into a hierarchy in a logical manner. So you learn syntax. You learn grammar, really, which makes it efficient, which is what you want. You want simplicity in science as you can achieve it. It's quite an art. So the next unit would be the 4th cosmic unit, which you could say is a nexal point, which for the longest time, from the 1960s to about the turn of the millennium, just 25 years ago, for about 40 years, they were called superclusters. That's still used, but it's a little bit outdated because these nexal points, these collections of galaxy clusters, have strands that connect them. And that forms what's called the cosmic web. which even the James Webb Telescope, interestingly named the James Webb Telescope, studying the cosmic web, we're trying to find out where the cosmic web ends. It doesn't. Which goes against a model called the model that is. I don't like to name it because it's rather anti-scientific. There's no such thing as a Big Bang. And if you disagree with that, that's fine. I'm not trying to start a fight. I'm just telling you the truth. There's no such thing as a Big Bang. Although there might be. It hasn't been fully decided yet, but you can't say that that's a known fact. It's a relatively known fact among certain astrophysicists who form a very large cartel and have a lot of power because they're funded by the government. There you see there's a problem, because now you're biased. So the Big Bang rose to ascendancy because of the government and the complicity of men who think that that's a good idea to adopt that model if you want to get the billions of dollars that the United States government gives out every year to people who toe the line, prejudicially, biased, totally anti-scientific, but not totally. Science is progressive. There's always a fuzzy edge. Well, in studying the universe, there's going to be a fuzzy edge. And currently it has an official name, which is anti-scientific. That's just the way it is. Don't fight with these men. Leave that to me. I know how to deal with those suckers. But you don't. And don't ever believe that you do. They'll kill you. I mean, metaphorically. All right, so let's go outward. We've discovered 4 cosmic units. Are there any more? There are. Although it's not commonly admitted yet, it is in the literature. They grudgingly, because it goes against their model. Do you know what the next higher cosmic unit is? Here's where it gets really, really amazing. And I hope you're interested in this, because this is just a little bit technical, in the sense we're going to have to fix our model that we're using of cosmic units. Because here is the most amazing fact among many amazing facts. It's the beauty pageant contest. But I'm trying to draw your interest. So what is the next highest cosmic unit that's beyond the cosmic web? It's something called a quasar. And this gets so interesting because it is very much like a star. Because a star is a ball of fiery plasma. What is a quasar? It's much more luminous than a star, but it is a single object, just like a star. So we found a second primary cosmic unit, and here's where we reach the cutting edge of astrophysics, which I hope you want to hear from the horse's mouth, but I'm just one man. You may want to get other opinions. You won't need them. I'll tell you the absolute truth. Although it's a little bit interesting to try to state what it is because we're not sure. We're very sure about stars. We know a lot about stars. We know a lot about galaxies. We now know quite a bit about cumuli, which is my term for galaxy clusters. We know a lot about the cosmic web, but we're getting less and less certain now because it keeps getting bigger. It's hard to see the whole thing. So the cosmic web is composed entirely of galaxy clusters, which are made of galaxies, which are made of stars. That all makes sense because they're luminous objects that fill the universe statistically. But the quasar is like a star, except it's a galactic scale luminous object of such intense brightness that words fail. And there are millions of them. We've cataloged millions of quasars. What are they? Can I be more specific? I can, but you're not going to hear this from anyone else. It's very logically stated what they must be. They're galaxies being born. It's the origin of a galaxy. A star is the origin of a solar system. But what is the origin of a galaxy? It's a quasar. It's a galactic scale object, much larger than a star. And it's hard to say exactly how large they are, partially because they're so bright. But it was progressively discovered all the way into this millennium that those objects are directly associated with galaxies. We can see structure. There are all scales of these structures that surround the quasar, except there's a gap, which really makes theorization or knowledge about these objects very difficult to decide. But one thing that can be said, they occupy the exact position of the center of a galaxy, which raises a very interesting question about the next cosmic unit that I know you've heard of because you've been brainwashed into knowing about the supermassive black hole, which is now stated as if it were a fact that there is a supermassive black hole at the center of every galaxy. That's not true, because you're saying that every galaxy has a black hole at its center. No. There's one of two objects at the center of every galaxy. It's either a black hole or it's a quasar. And a black hole, as you know, is so black and so much of a hole that it swallows light. Be very careful when you hear that said. That is not true. It certainly has not been proved. But it is the best guess so far, I will concede that. It looks like it's a super gravitational object. I'll be showing you in a moment that's not necessarily true, which flies in the face of the dominant model, so I'm putting my life in danger, metaphorically. Because a group of astrophysicists, just a statistically smooth group, that is fairly chosen. With me in the group, I would be the speckled hen and I would be pecked to death. That's not really science, but it kind of is, because science is ruthless with the truth. It's either true or it's not. Oh, that's not true either. It's either true or it's not, or we're not sure. And that's the correct, excuse me. I'll edit this, but I have to, pardon me. I'll put this on pause. This is sad but true, and you should know the darker side of life here. I am so poor that these are all the toothpicks that I have left, and I cannot afford to buy toothpicks. That sounds almost like an aphorism, a cliche, a proverb. He's so poor, he can't afford toothpicks. Oh my God. And that's why I need them. Just think of it as food in my teeth. You don't need to know what it is. Because I don't want to misguide the youth. Oh, the professor does tobacco. All right, I gave it away. So I'm a compromised wise man, if indeed that's even the right classification for me. Anyhow, we all have two sides, so let's just be generous and forgiving and kind. Yes, I'm a filthy old man, but I live alone. My wife died 16 years ago, so shut up. Excuse me. You should know this. This is part of life, okay? I could give you further examples of parts of life that we don't normally talk about, having to do with filth. All right, so there. Now my teeth are I'm sorry about that, but I'm not, because I'm too old to be sorry. Beware of a man who's emotionally elliptical. I like, not disturbed, elliptical. Isn't that a kinder, gentler word, to use George Bush's term, I believe? I'm citing that right. Kinder, gentler nation. Yeah, we're a very kind, gentle nation, and till it comes to the Islam nations. And then we're much kinder and gentler toward Israel. But that's your government. All right. So we have a new primary cosmic unit, the Quasar. Magnificently bright. And it took a long time to figure out what those things were. And it caused a huge controversy, which was quashed. One of my teachers, Halton Christian Arp, interesting middle name, Christian. Well, he's European, as am I. Excuse me, my cat needs to go out. I'm just going to put this on pause. And Halton Christian Arp took exception, essentially, with the model that would explain what a quasar is, because it's incorrect, and Halton Arp was right. Unfortunately, he sided with Sir Fred Hoyle, who missed out on a Nobel Prize because he turned into an asshole. And Halton Christian Arp was also... I mean, as a scientist, you have to be brave, which means you're going to be ornery. If you're going against the current model, you're on the defensive, which makes you combative. I've been through this many times, perhaps you have too, in whatever realm of science you deal in. If you have evidence that the current model is wrong, you're going to be attacked. Very harshly. In Halton Christian Arp, you may not credit this, but you can look it up. Wikipedia will tell you. He was drummed out of the American League of Astronomers because he wouldn't go along with the Big Bang. He disagreed with the theory of quasars. And his evidence is strong for... I don't like to compare one model with another, because a model is basically a developed theory which combines several theories to try to get a grip, as we're doing. But you can see we're now getting toward the cutting edge of astrophysics. Because what is a quasar? Well, I know, but so did Halton Christian Arp. Was he completely right? No. But he was much more correct than the model. And I would say that, for your sake, that's the best way to think of my view of the quasar. Much more correct than the model. But is it absolutely, provably true? No. And nothing is at this scale, yet. We're still trying. But we're still at the modeling phase, which is temporary, it must be, because you're just theorizing. Science is about knowing. Provably. All right. So that brings us to the next cosmic unit. Oh, yeah. Just recently discovered by computers within the past 20 years or so. Because of all-sky surveys, now that we have many forms of telescopy, we're able to do all-sky surveys in many wavebands, and the positions of the quasars in the sky have been plotted, millions of them. Millions of quasars, which are galactic-scale objects. They're the same basic size as a galaxy nucleus, but they're obviously not black holes. Are they related? Under my model, they definitely are. How would they be related? That has to do with quantum mechanics. And so I can't go into that at this moment because it would take us too far afield, but I hope you're enticed to listen to further video presentations. Or you can go back. I've covered this about a dozen times over the past 3 years. Well, actually, the past 2 years, because this is a discovery sequence that I'm in astronomy and in quantum mechanics, because I have a new geometrical approach to the universe. So there's a plug. So do we know of any further cosmic units? Let's count the ones we have: the star, the galaxy, which is made of stars, the cumuli, which are made of galaxies, and the strati. That's now called the cosmic web. I distinguish between strati and cirri, all of which are meteorological terms for clouds. Only stellae are not. But cumuli, that's a kind of cloud. And then the strati are the superclusters, which are nexal points. They're actually vertices in a polyhedral web. And it is linear, which is really significant, and I'll show you why in a moment. Only I know these things, so I'm just sharing a lot of information. Forgive me, but I want you to be interested and fascinated. That's the whole purpose of science. Well, from one aspect, because there's always two, right? At least. But really, you can always make it binary if you're clever. So I'm teaching you a lot at many levels. Now the cosmic level. Is there a cosmic unit beyond the four that we have? Stelli, nebulae, cumuli, strati, and Siri are one because they're all connected by the same cosmic unit, the cumuli. I hope I'm not going too fast, but this is condensing 6,000 years of human history. All right, so now we've reached the edge, have we? Not quite. There's the quasar. Now that is not a larger scale cosmic unit. It's part of what we call a galaxy. It's a galaxy being born. That is correct, but that's not acceptable to the model, so you'll never hear anyone else say that. But it is true. It's obviously true. And that's the danger of a model. It starts to suppress the truth. You get more evidence, such as with natural selection, which has been completely disproved. No, not according to those who believe in natural selection. It has not been disproved. Well, that's the cutting edge. And there are reasons for these things that actually do make sense, but you have to study both sides. Both sides. Never be prejudiced. Never be biased. That's anti-scientific. You have to be open-minded. To be a scientist, you have to train yourself not to be prejudiced, no matter what. Because governments make mistakes, and they're composed of a very large body of ostensibly intelligent men. Well, once you have that many men agreeing on something, you have to remember Carl Gustav Jung's principle, that the morality of a sufficiently large body of like-minded men is in inverse proportion to its size. Its morality is in inverse proportion to its size. Oh, I give you the example of the government. There you go. And churches. Highly prejudiced. Evilly prejudiced. Oh, it goes to morality all right. So we're talking about a galaxy. Where do they come from? The model is that they accrete. That gravity forms a galaxy. That has been completely disproved, but you'd never know it. Every textbook says that it's accretion. Well, that's Carl Gustav Jung's principle coming true. That's a danger. You never want to have that kind of a situation in science, but it happens with humans, which is not science. It's human. They're emotional. They want money, darling, money. And if the government is giving you billions of dollars every year to lie, you're going to lie, and I'm not going to scold you. Except under the strictures of science. I have to, because you're wrong. So, that's a quasar. But it doesn't form a new cosmic unit, does it? Well, the computers found out otherwise. By analyzing the All-Sky Survey plot of the millions of quasars. This is true, you can look it up. We have discovered millions of quasars. Do they form a group? Yes. And the reason you're never going to hear that is that also disproves the Big Bang. Everything that science discovers in astrophysics, deep space astrophysics from now on, will disprove the Big Bang for obvious reasons. It's wrong. So we're talking about wholesale liars, wholesale lies. And these scientists are not innocent, because if you're a scientist, you must be open-minded. They're not. And then you could say they're not scientists. I have said so. But that's very restricted point of view. It's true, but it's true in context. That's another huge principle that you have to master to be a real scientist, a real wise man. That's the goal. That's what we're getting to, and we're coming up on an hour. So let's complete our survey of the cosmic units that make the universe. We now have 5. What is the object called that the computers discovered, which has now been corroborated by human mathematicians checking? God damn, did these computers discover the disproof of the Big Bang? They certainly did. They're called, and I'm sorry, but this is the true term. You can look this up in Wikipedia. They're called huge, large. I know. Let me just reiterate. I did not make up this term. They're called huge, large. Why are they called that? Because the first ones discovered by these computers were called large quasar groups. LQGs they're called. But then larger ones were discovered, and then because men are so stupid with their choice of terms in science, I'm very strict about this. They simply added a new word. If something larger than the supercluster had been discovered, it would be like naming it the super duper cluster. That's what it means to call these things HLQGs. Huge, large. Huge, large. Well, that's scientific. No, it's not. It's not correct. But that's being a stickler. That's like in grammar correcting someone on their grammar. Nobody likes that, okay? Don't do that. I don't anymore. Although I do in context because I have to, because that's what science does. If you're not doing science correctly, somebody has to tell you. Well, then you get attacked. You get attacked. Because you're trying to steal their money. That's really how they think. They'll never say that, but that's the motivation. You're trying to hurt my money pipeline. You're trying to rob my puppy of puppy chow. That's really the reason for the Big Bang and all this controversy over modeling. But that's to give you an overall perspective that science is not antiseptic. It's dog eat rat. Because we're human. And when we form groups, a new kind of entity appears that Carl Gustav Jung pointed out. It has an entity-like capacity, and it's immoral. That's why Halton Christian Arp was forced out of the country. And this also happened to David Bohm. He was forced out of the country because his fellow scientists hated him. They hated David Bohm because he wasn't going along with Niels Bohr. That's true. You can look it up. There are whole books written on this. So we're getting to the huge, large quasar group. What is it? It is an object. And how do we know it's an object? This is an extended object, like a galaxy is composed of stars. This is an object composed of quasars, which are galaxies being born. They form groups in the sky, like constellations. Very little understood, on the order of 1 billion to over 10 billion light years in diameter. And when you're talking about a diameter, in this case, they're not necessarily spherical, because they conform vaguely to the cosmic web, which is a web, which is a interlocked series of polyhedra. I discovered that. Although it was known, I simply gave it a name that goes against the model. So what is a huge, large quasar group? It's a constellation in deep space that can be seen from Earth that's non-homogeneous, it's non-isotropic. It's anisotropic, or however that's pronounced. Pronunciation is a matter of personal taste, just as spelling was in jolly old England. Spell things any goddamn way you want. There's a good side and a bad side to that. So the huge, large quasar group is the fifth cosmic unit. Is there another one? There might be. We're not quite sure, but there are some very strange objects at the absolute limit of telescopy. They're called gamma ray bursts, which is just a interim name for something that's not completely understood. But they're so far deep in space, from our perspective, that we're not even sure what they are. But they're called gamma ray bursts or gamma ray bursters because they have certain characteristics that make them different from quasars. And they're extremely far away, further away than they could be, according to the Big Bang model. Once again, as I warned you, all new discoveries as they're made, first of all, will be suppressed. They will be misinterpreted, and they will be feared by the modelers because they're funded, they're biased, they don't want their goddamn model touched. Same as with natural selection. There will always be natural selection to the end of human history, no matter how stupid it is. Whether it's been disproved in every way, which it has. Almost. There are reasons for theories, even when they're wrong. If you don't have a better theory, even Wikipedia says, well, then you're stuck with your goddamn disproved model. I consider that to be anti-science. Wikipedia disagrees with me. So, as a consensual scientist, getting along with other scientists, as we must, I have to give in somewhere. Otherwise, you're just a lone wolf, and you're not going to accomplish anything. You won't be heard because you're irascible. And Halton Arp kind of earned, and so did David Both. These are gentle men. They're pure scientists, but they went against the modelers, and that's like going against the Catholic Church 1,000 years ago. They will literally murder you. 1,000 years ago. These days, they just get rid of you. You won't be funded. You won't be accepted. You will be ostracized. That's what happened to Zwicky, Arp, Bohm, and probably tens of thousands of others who went against some model. And they, in the case of natural selection, it's a war between religion and science. And that's quite real. Because everybody hated the Anglican Church. Charles Darwin feared it because he would have lost his standing as a British gentleman had he said that man is not made in the image of God, which is exactly what he said. Although he didn't like saying it. He was trying to be honest. It turns out that he was wrong about that, but he only said it once. What he was really talking about was speciation. Now, the reason I'm divagating is to give you perspective on science overall. And that's an hour. So I hope you enjoyed our tour of the cosmic units. There are 5.5 cosmic units. Well, that's quite simple. And there are whole chapters devoted to these 5 cosmic units. But there are only 5. In the next video, I'll talk about the supermassive black hole, the most mysterious object in its class that's ever been discovered. Highly controversial for obvious reasons. I'll disambiguate it for you so you have choices. That's all a scientist can really do for another human, is give you choices. You could be exposed to absolute proof of something anywhere from UFOs to anything else, and there they are, now we know. You just say, no, I don't accept it. Well, that's your right, up to a certain threshold, and we'll talk about that too. Your responsibility to your Creator. I used to be a pastor. I was a pastor in Kiev and in Yalta. I gave lectures on the Holy Scripture to people who accepted me over there. Nobody ever accepted me here. Well, a prophet is never respected in his own land. That's from the Bible. Stay tuned. You're going to get some really amazing information from a 70-year-old man who's devoted his whole life to wisdom, the ancient religion. Here comes the cat. She's here because she knows it's time to say goodbye. And there she is, that's Shar, the lab cat, without whom this production would not be possible. So thank you for tuning in. Don't forget to look up. It's still a full moon for one more night. But as you know, that's just a statistical average. It's continuous. And we'll talk about that too. Stay tuned. This is Anagalactic, bringing you the secrets of the universe and some information coming up that you can't afford not to know. Thank you.